This video is presented to you by www.testprepadda.com. Dear student, in the previous session of vectors, we saw the addition of two vectors. Now we'll deal with subtraction of two vectors. Now what is meant by subtraction of two vectors? Consider two vectors P and Q. So subtraction means we have to write vector P minus vector Q. Consider this as vector P and this as vector Q. Let us say angle theta, angle between the tails of the two vectors P and Q. This vector P minus vector Q I can write as vector P plus minus Q. Now think about the negative vector. Can you recall? Same magnitude but opposite direction. So what will you do? Before you use law of parallelogram of addition, we will change the direction of this vector and that will be like this. Keeping the same magnitude. Now if I complete the parallelogram, this is minus q vector, this is p vector, so this will be the resultant now. If I write this as vector c, it will be, now this angle, basically this angle can be said as 180 minus theta. So if I use the formula of getting resultant, that was p square plus q square plus 2pq cos theta. So now we will put this as cos 180 minus theta, which is p square plus q square plus 2pq. It will be minus cos theta. So it becomes p square plus q square minus 2pq cos theta. You can see in the case of addition, it was plus 2pq cos theta. Here it becomes minus 2pq cos theta. And if I consider the angle of this resultant with the vector p as beta, then this beta will be 90 minus alpha. Alpha was the resultant in the addition case. 90 minus alpha. So this was the subtraction of two vectors. Now you may ask that where do we use or where will we use this subtraction of vectors? So in physics, in future, you will deal with rate of change of velocities. What is acceleration? Acceleration is nothing but rate of change of velocities. Velocities are vector quantities. So if you subtract there, so we need to subtract vectors. So there we will deal with subtraction of two vectors. Now you can also get addition of more than two vectors, and in that case we have to use law of polygon of vector addition. What is this? I'll write here polygon law of vector addition. What we do here, head of one vector is placed at the tail of the other vector. For example, if one vector is vector A, another vector is vector B, you can see I have placed the head of vector A at the tail of the vector B. And if another vector is vector C, so three vectors, the resultant vector R can be found in this manner. And I can write here as vector R as vector A plus vector B plus vector C. This is the addition for more than two vectors. Now I will talk about a very special concept of vectors, resolution or components of a vector. Let me write here. Resolution or components of a vector. Dear students, before I tell you about resolution of a vector, I will tell you about position vector. Position vector of a point. Position vector. Consider a point O in the space or origin. If I take a plane, it will be two-dimensional, and if in the space, it will become three-dimensional. First, I'll take two-dimensional. So consider this as x-axis, this as y-axis, and a point P here with coordinates x comma y. So, and this as the origin, fixed point O. origin. This OP, this OP will be called as position vector for point P. Now, if I apply triangle law of addition, if I apply triangle law of addition, I will drop a perpendicular on x-axis. Let this as Q. This OQ length will be X. OQ length will be X. So if I write OQ vector, you know the magnitude is multiplied with unit vector, and you all know that for x-axis the unit vector is I cap. So it will become X I cap, and the PQ, this length is Y, and if I multiply this Y magnitude with the unit vector of y-axis j cap, I'll get the vector QP. It will be j cap yj cap basically. So with the help of triangle law of addition, we can write OP vector as OQ vector plus QP vector, and that is X I cap plus Y j cap. So this is the position vector of point P. If I try to find magnitude of this OP vector, and that is OP, it will be found by the Pythagoras theorem. You can directly apply. It will be root x square plus y square. That was two-dimensional. Now if I take a point P in the space, consider this as x-axis, y-axis and z-axis. All three are mutually perpendicular. This is point P, which has coordinates x, y and z, and this is the origin. So OP will be considered as position vector. If I drop a perpendicular from point P on xy axis and I consider this as R. So OR. Recall the previous case, two-dimensional case. R is a point. OR can be found, or better I say R is actually having coordinates x comma y. So vector OR can be written as x I cap plus y j cap, and this OP, this OP will be summation of this OR vector and RP vector. RP vector is what? Z is the magnitude and is in the direction of Z, so it will be K cap. So OP with the help of triangle of addition, it will be OR plus RP. So I can write this as xi cap plus yj cap plus z k cap. This is now OP, three-dimensionally. And if I ask you magnitude here, we know OR value as root x square plus y square. So here it will be root OR square plus RP square, and that can be written as x square plus y square plus z square. So if any position vector is given, we can get magnitude this way. Now consider 2 points in the space. 2 points. If I take x-axis, y-axis, and z-axis. 2 points, let us say point P1 and point P2. Point P1, let us say x1, y1, z1, and point P2 as x2, y2, z2. OP1 will be the position vector for point P1. OP2 will be the position vector for P2. So OP1 I can write as x1 I cap plus y1 j cap plus z1 k cap, and OP2 I can write as x2 I cap plus y2 j cap plus z2 k cap. Now P1 P2, P1 P2, this vector is actually considered as a displacement vector. P1 P2 is considered as displacement vector. For example, in the space, you move from point P1 to point P2. You can adopt any path, but the resultant or displacement will be P1, P2. Now, if you use the triangle of addition, OP1 plus P1 P2, vector OP1 plus vector P1 P2 will be equal to vector OP2, and from here P1 P2 vector will come as OP2 vector minus OP1 vector, that is second vector minus first vector. So if I substitute OP2 minus OP1, it will become x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap. Now I will keep the terms of I cap together, so it will become x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is displacement vector P1. Now if I try to find magnitude P1, P2, it will come as root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Now please note that this magnitude displacement will always be less than or equal to distance. Now I will talk about resolution of a vector, components of a vector. Uh, till now we have talked about resultant vector of 3 vectors. Means 2 vectors are given and by the addition we get resultant vector, or 3 vectors are given, by the addition we get a resultant vector. Now we will talk about dividing one vector into 2 or 3. Consider xy plane. xy plane. This is x-axis, y-axis, and a point A. This is A. Consider this OA as vector A. Drop a perpendicular from A on x-axis. Let this as B. Drop a perpendicular from A on y-axis. Let us say this as C. OA is vector A. This OB is actually projection of OA on x-axis. So OB is the projection of OA on x-axis, while this OC is projection of OA on y-axis. So according to rules of vector addition, I can write OA is equal to OB vector plus OC vector. This I can write. And OB, if I consider alpha angle the OA is making from x-axis and beta from y-axis, OB will be the length OB will be A cos alpha, while OC length will be A cos beta. So I can write this OA as A cos alpha, that is the magnitude on x-axis, and I cap is the unit vector, plus I can write A cos beta, and what will you write here, which unit vector? J cap. So this OA is resolved into two parts, E cos alpha I cap and E cos beta j cap. If I take a vector three-dimensionally, then it can be resolved into three parts. There, what will you say? A vector A, I can write as E cos alpha I cap plus E cos beta j cap plus E cos gamma k cap, where E cos alpha, E cos beta and E cos gamma, these are the components of vector A along x-axis, y-axis and z-axis respectively. So this is about the components of a vector. We have divided vector into components on x-axis, y-axis and z-axis. Now I'll take one question to understand this concept in a better manner. The question says, resolve a weight of 20 Newton in two directions which are parallel and perpendicular to a slope inclined at 30 degrees to the horizontal. This is the question. Now, if I take that slope which is at 30 degree from the horizontal, it says a weight of 20 Newton. This I say 20 Newton. I have to resolve this weight into two parallel and perpendicular. So parallel means this one and perpendicular means this one. If this angle is 30 degree, this angle will be, this is 90 degree, this will be 60 degree. So the component which is parallel to this slope will be 20 cos 60 degree, and this becomes 20 into cos 60 degrees half, so it becomes 10 Newton, and this component is parallel to the slope. Now the perpendicular, this was the parallel component. Now the perpendicular component will be 20 cos 30 degree, or you can say 20 sine 60. This angle is actually 30 degree. So it will become 20 into root 3 by 2. Root 3 by 2, which can be written as 10 root 3 Newton. So the given weight is resolved into two directions, parallel and perpendicular to the slope. The parallel component is 10 Newton and the perpendicular component is 10 root 3 Newton. This is about the resolution or components of vectors. In the next video of vectors, we will learn about the multiplication of different vectors. Different types of multiplications are possible. We will learn in the next video. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.